Hello again. How are you doing today? I'm doing pretty well myself. Today we're going to talk about dividing fractions, which I'm sure you expected because we just finished adding and subtracting and multiplying them. The nice thing about dividing fractions is it's not difficult at all. As a matter of fact, we're going to use most of the things that we learned last lesson when we were multiplying fractions. Let's think about division. If you wanted to talk about, say, 10 divided by 5, there are a number of ways that we could represent this. We could start off with this kind of house framework and put the 10 inside and the 5 out here, and that would mean 10 divided by 5. You could use the division symbol, or you could write it in fraction form. This house thing, that's not going to get used very much anymore. That's rather old school. But let's look at the other two. Let's say we have 10 divided by 5. You know the answer is 2. And you know that eventually this should produce nothing different than writing 10 divided by 5 this way. Somehow we should be able to convert from the division symbol to the fraction bar. If we're going to be working with fractions, well, let's get some fractions in the mix. 10 is 10 over 1. And 5 is 5 over 1. So that's not such a big leap. If we come backwards here and think about 10 in the numerator and 5 in the denominator, we can imagine obtaining this by keeping 10 over 1, because then the 10's in the numerator. And in order for the 5 to be in the denominator, we'd have to multiply by something that had 5 in the denominator. So this would work. 10 times 1 is 10, 1 times 5 is 5. These things have to be equal. Let's look and see what we have here. The first fraction hasn't changed a bit. The second fraction is a little different. We went from 5 over 1 to 1 over 5. Those are reciprocals. And then we also made this change. The division turned into a multiplication. And that's pretty much how division of fractions works. If you're going to divide by a number, it's exactly the same as multiplying by the reciprocal of that number. We had something similar to this a while ago when we were talking about adding and subtracting signed numbers. We said that subtracting was the same as adding the opposite. And all of these things work because multiplication and division are inverse functions of each other, and of course addition and subtraction are inverse functions of each other. So let's write this down so we can keep track of it. If you have the first number divided by the second number, you can rewrite this as the first number multiplied by the reciprocal of the second number. So we can't just change division to multiplication. You know that multiplying by 5 is completely different than dividing by 5. But we can change division to multiplying by the reciprocal. Let's look at this in a different way and scroll down to the page. When you are writing 10 divided by 5, you're asking a question. The question is, how many 5s happen to be in 10? And of course the answer is 2. You're asking the same question when you write 2 divided by 1/4. You're saying how many fourths are in 2? We could draw a picture of this. This is not my best picture, but that's supposed to be a whole circle. And I can divide it into fourths. And since we're asking how many fourths are in 2, let's get a picture of 2 whole pies. And now it's really easy. How many fourths are in 2? Well, that answer is 8. 1, 2, 3, 4, 5, 6, 7, 8. We can just count them. If we use the rule up there in the yellow box to figure out the answer to 2 divided by 1/4, we would keep the first number the same, change the division to multiplication, and multiply by the reciprocal of 1/4, which is 4/1. Oh yeah, see? That's where the 8 comes from. It works out really nicely. So we don't actually have to learn any new procedures except to rewrite division as multiplying by the reciprocal. So let's try one. Flip the page. Here we go. Let's divide 21/25 by 9/20. 9/20 is kind of small compared to 21/25, so we might expect it to go in there at least once, maybe twice, maybe only once and part of the way. Let's see what happens. The very first thing we need to do is change the multiplication to division, and then change that second fraction to its reciprocal. I'm going to write this out over here just so we can make some notations. So the first number stays the same, 21/25, divided by 9/20. As we rewrite this, we say that it's equal to 21/25 multiplied by 20/9. So let's get a little notation here. Right here, right, we change the division to multiplication. And here, we take that second fraction and we use the reciprocal. After that, there is nothing new here. You know how to do this. We would look at 21, see if it has any factors in common with anything down in the denominator. I believe there's a 3 in 21 and also a 3 in 9. So we'll take 21 and rewrite it as 3 times 7. We'll take 9 and rewrite it as 3 times 3. And then we look at 20 and 25 and see if maybe there's anything in common there. And there's a common factor of 5. So 20 is 5 times 4. 25 is 5 times 5. And then we're just looking for those common factors. Right? 3 over 3 is 1. 5 over 5 is 1. And we multiply what's left. 7 times 4 is 28. 5 times 3 is 15. That's improper, so we'll convert it to a mixed number. 15 goes into 28. Well, not quite twice. It would go in there twice if it was 30 up in the numerator. So it goes in there one time with 13 left over. And that's pretty much it. 21/25 divided by 9/20 is 1 and 13/15. Okay, we have the calculator handy. We should make sure that the calculator works just as well as our paper and pencil. And let's give this a try. Let's start with the fraction key. We have 21 in the numerator, 25, whoops, back that up, 25 in the denominator, divided by, new fraction template, 9 in the numerator, and 20 in the denominator. And let's see what it has to say. Well, there's the 28/15 we had before, and then you remember that the fraction converter is right up here, written on the calculator. And there we are, 1 and 13/15. And so we're feeling pretty good about our answer and about our calculator skills. Not a lot changes if we're dealing with mixed numbers. We'll do exactly the same thing we did when we were multiplying. We're going to turn all of those mixed numbers into improper fractions and then calculate. But of course, before we do, we should think about estimating the answer. Let's look at this second example. 12 3/10 is, well, let's see, 5/10 would be half, so it's closer to the 12 side. So if we were estimating, 12 3/10 would be about 12. 4 1/5, that's definitely closer to 4 than it is to 5. So that's about 4. And that means that if we were going to estimate that 12 3/10 divided by 4 1/5 should be about 3. Not exactly 3, so that's why we have those little squigglies. Let's see what it comes out to be. All right, first step. Rewrite the mixed number as an improper fraction. 10 times 12 is 120 plus 3 gives us 123 tenths. We still need the division symbol here, so don't jump the gun and try to make some sort of weird reciprocal out of this. 5 times 4 is 20, plus 1 is 21 fifths. And now we can rewrite it. Keep the first fraction the same, 123 tenths, but then multiply by the reciprocal of the second fraction. All right, that's pretty much where we're at. All right, we changed the division to multiplication. We took the second fraction and used its reciprocal. You know what to do from here. Why don't you go ahead, pause the recording, see what sorts of common factors you can find, and then come back and compare your answers with mine. Let's see what we have here. 123. 123 is divisible by 3 because if I add up the digits, 1 plus 2 plus 3 is 6, the answer is divisible by 3. It's kind of a nice trick that only works for 3s and 9s. So we should probably check here. Actually, I could have done this in my head, I guess, because 12 is divisible by 3 and so is 3. But 123 divided by 3 is 41. So we have 41 times 3 in the numerator, and that was handy because of course 21 is 3 times 7. 5 is prime, so that's not going to break down. And in the denominator we have 10, which is 2 times 5. And there we go, a few common factors. 3 over 3 is 1, 5 over 5 is 1. Let's see what we have. 41 is all by itself in the numerator, and the denominator, 2 times 7 is 14. 14 goes into 41. Oh gosh, I don't know. 14 times 2 is 28, plus another 14 would be 42. That's a little too much, so it's just going to go in there twice. Oh, maybe we got to write this down. 41 divided by 14 goes in there twice, gives us 28. Do the subtraction. 13 left over. So 2 and 13 14ths. Just about 3, like we thought. And there's our answer. And of course, you could do this on your calculator. You know where the mixed number template is, and it should come out to be just fine. So here at the bottom of your page, you have the steps for dividing fractions. They're just about the same as the steps for multiplying fractions. The first step is to rewrite any mixed numbers or whole numbers as improper fractions. We had to do that before. The only thing we did differently was the second one, where we rewrote it as multiplying by the reciprocal. And after that, all the steps you already know. So let's see what we can do with some division problems. And flip the page. A lot of people have difficulty with application problems, especially when fractions are involved. I think the fractions just sort of make people's eyes go buggy and make their brains stop for a little bit. So when you're reading, read it once. Don't let the fractions intimidate you. Read it twice, and then think about what would happen if you didn't have fractions. Maybe give yourself a for instance and turn a fraction into something like a whole number, make this a different whole number, and see what your answer might be. Whatever you would do with the whole numbers is the same operation you would do if there were fractions. Division happens when we are trying to divide something into equally sized pieces, if you're going to share or somehow cut something up. If you are repeatedly subtracting until the original quantity is gone, whenever we want to undo multiplication in an algebraic sense, we have to divide. And of course, you've already seen times when the units involve the word per, and that tells us instantly exactly what needs to be divided by what. So let's see what we have here. A freestanding ice machine has a tank capacity of 1 4/5 liters of water. Each ice cube uses 1/50th of a liter. And the question is, how many ice cubes can the machine make from a full tank of water? So what we really want to know is how many 1/50ths are in 1 4/5. And so you can think of this a couple of ways. You can think of it as all of the water, and then we'll take out the amount for one ice cube, and then take out the amount for another ice cube, and then take out the amount for another ice cube, and feel that repeated subtraction. Or you can think about the ice cubes as being those equally sized pieces. And so we're chopping that 1 4/5 liters up into those equally sized ice cubes. Either way, we realize now that this is going to be a division problem. So let's answer the question. How many 1/50ths are in 1 4/5? And of course, the setup starts as 1 4/5 divided by 1/50th. Not because 1 4/5 is the larger number, but because of the way this is worded, are in this. So we're starting with the 1 4/5 amount, and we're chopping it up into pieces of this size. All right, let's see. You know what? I think I'm going to let you guys take this one from here. You know what to do in terms of writing this mixed number as an improper fraction. You have the steps on the page before. Why don't you pause this recording, give this one a shot, and see what you can do. Come back when you're done. All right, let's see how it all worked out for you. 5 times 1 is 5, plus 4 is 9. So as an improper fraction, 1 4/5 is really 9/5. We need to divide by 1/50th. We know that this is the same as multiplying by the reciprocal, and the reciprocal of 1/50th is 50 over 1. 9 breaks down, but it's not necessary to break it down because the 3's aren't factors of anything that's in the denominator. 5 is a factor of 50 though, so we should probably factor the 50. So we have 9 times 5 times 10, and then in the denominator, there's a 5. And certainly 5 over 5 is 1. 9 times 10 is 90, and the denominator still has that 1 there, but that's okay. We know that that answer is 90. The question is 90 what? Never forget your units. Always consider writing your answer to an application problem as a sentence so that you know your answer is reasonable and you know the units you choose are making sense as well. How many ice cubes can the machine make? This can make 90 ice cubes. All right, let's try the next one here. The amount Joe pays for rent is 3/7 of his paycheck. He actually pays $1,140 a month for rent. The question is, how much does he earn each month? So we really want to know what's his paycheck. If we look up here, we have 3/7 of his paycheck. And last lesson, we learned that this was a multiplication indicator. So let's see what we have. We have 3/7 of, that's multiply, of the paycheck equals his rent. There, a word equation is not a bad way to start because then we can fill in some values where they belong and use variables for some things that we don't know. So we have 3/7. Let's call the paycheck P. We'll write that over here. P equals the paycheck. 3/7 of P is equal to the rent, and that's $1,140. Okay, so now we need to isolate this variable P, and before, if there was something, let's see, maybe don't write this down, but just watch for a second. If we had something like this, where 2x was equal to 10, you would have just divided the left side by 2 and divided the right side by 2 and decided that x was worth 5. So it's natural if you think that you would like to divide the left side by 3/7 and the right hand side by 3/7. So don't write this down just yet. Just watch. If I divide the left side by 3/7 and I divide the right side by 3/7, you see what happens, how ugly this is? I've got fractions within fractions, and depending on the values that I'm using and whether or not I look away from my paper, I might mistake which fraction is where and where the main denominator and numerator are. Is this really 3/7 in the denominator? Or when I'm using pencil, what I might think that the numerator is 1140 divided by 3. This has just got problems written all over it. So we need a better way. Rather than dividing both sides by 3/7, we can go back to that rule we already know. Division is the same as multiplying by the reciprocal. Okay, so I'm going to erase all this stuff here. And there we go. And now you can get ready to follow along again. So rather than divide both sides by 3/7, we're going to multiply both sides by the reciprocal. Hang on, I want to get rid of this other stuff here too. There, magic. Okay, so let's just bring this line down. 3/7 is being multiplied by P. And I have 1,140 on the right-hand side. So what I want to do is multiply both sides by the reciprocal of 3/7. And of course, the reciprocal of 3/7 is 7/3. And let's see what happens here. 7 over 7 is 1. 3 over 3 is 1. And that leaves us with P all by itself. On the right-hand side, we have 1,140 times 7, all divided by 3. Does 3 go into 1,140? Well, let's see. 1 plus 1 is 2, plus 4 is 6. 3 goes into 6, so 3 goes into 1,140. How many times? 1,140 divided by 3. 380 times. Okay, so this is really 380 times 3 times 7. Remember, the 7 was still there. There's a 3 in the denominator. Cancel the common factors. And let's see what we have. P is equal to 380 times 7. 2,660. Okay, well, we said P was the paycheck. That's pretty good. We want our paycheck to be larger than the rent, right? So it's a good thing we didn't somehow divide or multiply the wrong things in the wrong places. This sounds pretty good. Joe earns 2,660 what? Dollars each month. So what's the big lesson here? Rather than dividing by the fraction, what we're going to do is multiply both sides of the equation. by the reciprocal. So that fact that dividing by something is the same as multiplying by its reciprocal comes in really handy. And we're going to use this idea a whole lot in a future lesson. For now, have fun dividing, and we'll talk to you again in a little while. Have a great day. Bye-bye.